Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Ainu Atira binti Zulkarnain. I will present you the final year project 1, which is analysis of lubricated contact of biological implants using pin on disc. I am the student under the supervision of Mr. Muhammad Mazwan bin Mahad. Okay, firstly, I want to present you the project summary. This project studies the analysis of lubricated contact of biological implants using pin-on-disc. Okay, the artificial implant surgery has been a success. However, there is still issues about the lifespan of the artificial implants after the surgery has been done. Okay. After analysis on the problem, this study focused on reducing the friction and wear rate of the artificial implants by adding the lubrication to increase the lifespan. Next, the project background. The artificial implants have been designed to replace the natural cartilage that has been damaged due to several factors, such as an accident. Okay, next, at the body, there are fluid which called as synovial fluid. This fluid functioning by ensuring that the part of a body, such as knee, can protect the knee bones and make sure it will not rub together. However, after the surgery of cartilage replacement, even though the cartilage has been replaced with the artificial implant, the body still produces the synovial fluid. However, the synovial fluid that has been produced after the artificial implant has been done might not be able to thicken the fluid film which to protect and reducing the friction and wear rates of the artificial implants. Next, the problem statement. First, this project is to identify how the use of different lubrications affects the wear and friction of the artificial implants. Secondly, to determine whether the use of different lubrication can increase the lifespan of the artificial implants. Next, the objective of this project. First, to establish the coefficient of friction, the wear thickness, the total deformation at the pin on this based on the different material characterization of lubricants. Next, to determine the value of wear thickness. Next, the one meter stress and the total deformation of dry lubricating at pin on this using ASIS software. Okay, for the scope and limitation of the project. This project analyzed using ASIS software. This process determines the wear thickness, the deformation of the pin, the von Mises stress using dry lubrication at pin on this at different time by applying pressure of 12.88 megapascal. Next, the methodology. A pin on this model was developed and simulated using ANSYS software. Next, on the ANSYS workbench, the transient structural modulus is utilized to generate the pin and this 3D model in the geometry section. The material is defined in engineering data. Next, the surface knobs were changed to reflect the redefined meshing. Lastly, the data has been obtained for the wear thickness, for the volume loss, for the von Mises stress, and the total displacement. Next, the flowchart. Firstly, this project surveys about the literature. Next, the problem definition of this project. Okay, then choose the material for lubrication contact as the project objective. The material has been chosen and they are the albumin, the phospholipid, and the bovine serum. Next, the problem solving using ANSYS software. Okay, the project has been drawn. Then, the analysis and simulation at pin on disk of the lubrication has been done using ANSYS software. the result has been obtained for wear thickness, the volume loss, the form stress for the dry lubricating contact. Next, the preliminary result. Okay, after the result has been get from the ANSYS, we has determined that the wear thickness, the volume stress, and the volume loss due to wear, total deformation using ANSYS. As you can see, this is the deformation at the pin on disc using ANSYS software. Next, this is the one stress of pin on disc using ANSYS software. As you can see, the value for maximum is 2.7156 the power 10 of 7, and the minimum is the 8.2545 the power of 6. Okay, next, the preliminary result for the total deformation at pin on disc. The maximum peak is 0.12. Next, the graph for volume loss due to wear versus time. Okay. Next, okay, this is the we have obtained the result for simulation, which is the volume loss that value 0.08027 millimeter cube. Okay. We have calculate the pressure, which is 12.88 megapascal using the formula force divided by cross-sectional area. Okay, the force we take average load for a person, which is 66 kilogram times by 9.81 to obtain in the Newton. Okay, so this formula. Okay, next, after we have obtained the volume loss, we have obtained the wear thickness. Okay, we can calculate the wear thickness using the formula volume loss divided by cross-sectional area. So the wear thickness is 1.6 times 0 times the power of negative 3 millimeter. Next, the expected result. Okay, at the end of this project research, which is the next semester, the expected result will be about testing 3 lubrications that has been chosen. This lubrication will be tested by analyzing their characteristic. For example, the viscosity, density and compressibility, the lubrication wear rate, the frictional force, the deformation and the volume stress. Okay, the test for the artificial implants and to be tested on pin on disc developed using ANSYS software. Okay, next, this is the expected result that we gain from the journal at the internet. As you can see, this is the graph for the weight loss for the pin material. Okay, based on the graph, the wear rate was the highest for the globulin compared to albumin serum, even though the same amount of load has been applied, which is 10. Okay, so but the albumin is still the highest. This result show different type of lubricant give different wear rate. Okay, that's all from me. Thank you so much. Assalamualaikum.